All right, well, we are going to get your brain back in gear after spring break with a speed drill. So take your speed drill and review exercise booklet out, turn to page 24, and we're going to start with speed drill 22 today. Some addition, some subtraction, some multiplication, just kind of an assortment of mathiness to get your brain thinking numbers. You're going to have 3 minutes for the speed drill, and you may begin. Should be halfway. One more minute. Lana's already done. Joshua's done. For the sake of those watching the video, we'll get 45 seconds long. One stop, and if you would put your pencils away, take out a pen. Pencils away, take out a pen. If you could reach across and exchange with each other, and reach across and exchange with each other. I forget, you don't have my length of arms. All right. It's worth a try. All right, what? You don't have to. All right, these are 5 points each. 5 points each. Going across the top row, just cross it out if it's wrong, otherwise don't make any marks at all. Going across the top row, 107, 49, 210, 465, 127, 17, 144, 127, 102. Next row going across, 336, 48, 170, 255, 162, 9, 308, 28, 392. I figured the score to the best of your ability. They're 5 points each, and if you would, Go to the score page at the beginning and write their score next to where it says Speed Drill 22, our first speed drill of this final quarter of the school year. Speed Drill 22, if you'll write that score that they earned. And just leave it open to the score page so I can return it to them. So great job, Lana.
2, not 100.
And as Josh pointed out, you have only 2, not one, that looks like 3. 3 not 100s all year long. And Josh, another 100 as well. So great job on that. Let me go and collect those back from you then. So Lana's tearing it up on these speed drills. And let's go and review some things we talked about before spring break. Seems like a long time ago. We talked about terms, and I use this terminology, like terms. Now, what does it mean to have like terms, Lana?
That they have the same variables.
Good, the same variables. So if I had, for instance, a 3ab and a negative 7ab, these would be like terms, correct? What about a negative 3ab squared and a negative 7ab cubed? Would those be like terms? No, because this only has 2 b's, that has 3, so the variables aren't exactly the same. If you have like terms, though, we said they could be added or subtracted. I could add these terms together. And what would I get if I added a 3ab squared and a negative 7ab squared? Joshua?
Negative 4ab squared.
Good, a negative 4ab squared. We said we could also subtract. Of course, we never really subtract in algebra, Lana. We said we add the...
Wait, you changed the, inverse.
At the inverse, there we go. Good. You're right, though we do change the subtraction to addition, and we change this to the inverse, the positive 7ab squared. So if we'd subtracted those terms, we would get
10ab squared.
10ab squared. Notice that the letters stay exactly the same. It's just 3ab squares, 7 more ab squares gives us 10ab squares. However, we could multiply terms together. They don't have to be like to multiply, but we certainly could multiply monomial terms together. And we said we have 3 steps to multiplying monomials. Do either of you remember the 3 steps? It was a week and a half ago.
Sign, number, letter.
Hey, that's really good. Sign, number, letter.
Yeah.
So here, let's go back to what we originally had. Since the signs are different, automatically at class, I'm going to get a negative. As far as the number, just multiply. 3 times 7? 21. And as far as the letters, we said when we multiply like bases, we add the exponents. Hey, good, Josh, good. So when we multiply the like bases here, we're going to add the exponents, class, to get a
to the
squared and the b
to the fourth.
to the 4th when we add the exponents. So a little reminder there. Of course, we could have also worked in, say, a negative 2b right there. Well, now all of a sudden it changes those things just a little bit. Now in a series of multiple factors, you have to figure how many negatives do you got? Well, I got 2 of them. That's an even number, so I'm going to get a positive. Then 3 times 2 times 7. 42. I still only have an a and another a, so a squared, but I've got a b squared, a b, and another b squared, b to the 5th, as we add the exponents. Do you remember talking about this? We also talked about dividing monomials. So we said again, they don't have to be like, but when we divide, maybe a 35 a cubed bc to the 5th by, let's just say, a negative 10 a cubed b cubed c cubed, for instance. Well, as we divide, we look at the signs. They're different, class. That means we get a negative. Of course, that's boring. We get a negative earlier. Let's say they're both negatives. You get a positive because they'd be the same, right? So if the signs are different, just like in multiplication, you get a negative. If they're the same, you get a positive. Now, the number's a little bit more tricky because you could multiply 35 and 10 together, right? You can multiply anything you want. You can't always divide. And here's an example where you can't really divide 35 by 10. But I said if you can't divide, treat this like a fraction and just reduce it. So instead of just saying, well, I can't divide 35 by 10, reduce it down to 35 tenths down to 7 halves, right? Pull the 5 out of both of those. And then as far as the letters go, I said if you ever have two letters that are exactly the same with the same exponents, well, they cancel, right? And when they cancel, technically, it would give you a 1. But do I really need to write the 1? No. Here, I've got a b to the first and I've got a b cubed. We said when we divide like bases, we subtract the exponents. So b cubed divided by a b to the first, when we subtract those exponents, the class gives us b squared. But where do I have to write it?
In the bottom.
At the bottom, because that's where the bigger power was. It's as if this 1b came along and canceled one of the 3 b's, but there's still 2 in the bottom. Here I've got a c to the 5th and a c cubed. Well, again, I subtract the exponents to get
c squared.
C squared, but it's going to be in the top because the bigger power was in the top. Do you remember doing this before break? Okay, so brain's a little bit refreshed. Turn your books to page 484. We're not going to do anything new today. Today's whole purpose is review the stuff we already talked about. Just make sure we're back in the groove. We're good to go with this. Maybe if there's little weirdnesses that pop up, let's catch and make sure we're good to deal with them. But page 44, for starters, we just want to look at numbers 1 through 6. Are these like terms? If they are, go ahead and combine them. If they're not, just not like, no like terms. So page 484, I want you to look at the 1 through 6 in the chapter 10 review A. All the way at the bottom of the page, that 1 through 6. If they're like terms, go ahead and combine them. If not, just write no like terms. Remember, as you combine like terms, leave the letters, the literal coefficient, alone. Let's see how we did here. Number 1, what was your answer? Joshua?
I just put no like terms.
No like terms. Literally, your answer is 5n to the 5th minus 2n squared. You can't combine anything.
Oh, I didn't see the end of the 5th.
Your brain filled in an n squared, so you had 3n squared for your answer?
Yeah.
Careful there. How about number 2, Lana?
5A.
5a is correct. How about number 3, Joshua?
No.
No like terms, can't do it. 2xy minus 2xe is your answer. Number 4, Lana.
9A squared B.
Good, 9a squared b. How about number 5, Josh?
2. Wait. I know all the x squares cancel out.
Oh, no. You're not doing, when you're combining like terms, you don't even mess with the letters. You just make sure they have the same letters.
Oh, right.
So it's just 4 plus 3 minus 5 gives you
Yeah,
2x squares.
X out, right.
Yep. So you have 4x squares, then you have 3 more x squares, now you have 7x squares, then you take away 5 of those x squares, now you have 2x squares left over. Again, the x's, to just keep them along for the ride. Now, number 6, again, you're only going to combine the terms that are actually like. So, Lonnie, you should have found a 6n squared to be like to another 6n squared to get
12n squared.
But Joshua, you also should have seen that the 4mn squared is like to the negative 1mn squared, which would give you
3n squared.
So your answer is 12n squared plus 3mn squared.
You know what other way?
You could have 3mn squared plus 12n squared, absolutely. Good question. All right, questions on 1 through 6. Questions on 1 through 6. All right, let's go ahead and look now at number 7 through 14. You've got some multiplication, you've got some division, so you're either going to add the exponents or subtract the exponents. Do 7 through 14 now. They're on page 484. 7 through 14. Shouldn't take but about a minute to do all 8 of these. Joshua, what'd you get for number 7? H to the 9th, because we add the exponents. Number 8, Lana.
T to the 6th.
T to the 6th, because we add the exponents. Number 9 is kind of a weird one, Joshua.
And J to the 5th.
Well, M squared, J to the 5th. Don't lose the squared on the M.
Oh, right,
but yes,
right.
M squared, J to the 5th is correct. Number 10, Lana.
D squared.
D squared, because we subtract the exponents. Joshua, number 11.
1 over W.
Good. When we subtract the exponents, we're left with a W to the first in the denominator, or just a W. But you have to have something in the numerator, so we have to put the 1 in the numerator to fill the spot. 1 over W. Yes, ma'am.
But, wow. I not do minus 1 as third or second problem.
Gotcha. Okay. How about number 12 for redemption, Lana?
A to the 8th B cubed.
Good. A to the 8th B cubed. Technically, you could put over 1. You could put a 1 in the denominator. Really don't need to. It's only 1's in the numerator that must be written. Number 13, Joshua.
J to the 10th.
J to the 10th. And then number 14, Lana?
U squared V to the 7th.
Good. Again, subtracting those exponents, U squared V to the 7th is correct. Questions on that? All right, do numbers 15 to 24 now. 15 to 24, more of the same. 15 to 24. They're on page 485. I don't care. All right, let's go ahead and take a look at this together. Number 15. Lana, what did you get when you added the exponents?
8 to the 7th.
8 to the 7th. Good. Number 16. Joshua, when you subtracted the exponents? 1. They canceled away. Basically, u to the 0, sure, but if there's no u's, there's no u's. So all that's left is the understood 1. Good. Number 17. Lana. X to the 47th. Aren't you glad you got to use exponents? Didn't write x, 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 x. Well, anyway, you get the idea. Number 18, Joshua, subtracting the exponents.
G squared.
G squared. Number 19, Lana, adding some of the exponents. H cubed k to the 11th. Very good. Number 20, also adding some of those exponents there, Joshua. P cubed q to the 4th. Good. Number 21, subtracting some of the exponents there, Lana. F squared over z to the 7th. Good. Number 22, same thing, Joshua.
W6 over b to the 11th.
Over b to the 11th?
I mean, not that. W6 b to the 11th times.
There we go. But which letter should come first alphabetically? Now, in all fairness, they messed you up by putting the W before the B. It should have been B to the 15th, W to the 6th over B to the 4th. But yeah, B to the 11th, W, not W6, but W to the 6th. So B to the 11th, W to the 6th should have been our answer for 22. Lana, number 23. B to the 28th power is correct. And number 24, Joshua.
A squared over b to the 4th.
A squared over B to the 4th. Any questions on those? All right, some little things there to watch for. All right, now that's been all just letters. Add the exponents, subtract the exponents. Now let's get back to monomials, sign number letters. So we're going to have signs to worry about. We haven't had those the last several problems. We're also going to have numbers to take care of. I want you to do 25 to 32. 25 to 32. 8 problems. Let's see if we can go 8 for 8. Take a little bit longer these because you're thinking sign, number, letter on each. All right, let's see how we did on these. Number 25, what did you get when you multiplied, Joshua?
AC cubed. I meant 9c cubed.
9c cubed is correct. Number 26, Lana.
Negative 48 q to the 7th.
Good, negative 48 q to the 7th. Number 27, Joshua.
10m cubed into the 4th.
Good, 10m cubed n to the 4th. Good, putting the m's before the n. Number 28, Lana.
Positive 12 s to the 7th t to the 9th.
Good, positive 12 s to the 7th t to the 9th. Of course, you could leave that positive, understood. Number 29.
Still put it in alphabetical order.
S to the 7th, then t to the 9th? Q, R, S, T, U.
Yeah,
V, W.
I'm dumb, sorry.
It's okay. You'd be amazed how many times I have to think through the alphabet. I'm like, which one comes first? Especially some of those later letters. Hey, like A, B, C, I got those three, right? Like X, Y, Z, I got those three. But anyway, all right, number 29.
S to the 7th, t to the what?
T to the 9th. Because you got a t squared and a t to the 7th, add the exponents t to the 9th. All right, number 29.
30p to the 17th. I mean, negative 30p to the 17th.
There's one more letter there. Ah, did you cancel the q to the 6ths?
Yeah.
But you're not dividing, you're multiplying. So we add the exponents to get q to the 12th. There we go, negative 30. P to the 17th, q to the 12th. Should have been our answer there. Number 30, Lana.
Negative 3x to the 13th, y to the 11th.
Good, there's an understood 1 there. So when you multiply sign, number, letter, it's negative 3, x to the 13th, y to the 11th. Good. Number 31's written kind of weird. Normally you'd have each of those separate monomials in parentheses. They did a random multiplication in the middle. Doesn't matter. Remember, associative principle doesn't matter what's associated if it's all multiplication. Joshua, what did you get on 31?
15a squared c to the 5th.
It is not. I've got a, signs obviously everything's positive, right? So I've got 5 times 3 times 2.
6. Wait, 5 times 3 times 2 is 30.
30, okay. Then I've got an a squared that has no friends, like Glenn, so. Poor Glenn, he's just minding his own business back there. All right, so we keep the a squared, right? And then I've got a c cubed, I've got a c, and then I've got another c squared.
Yeah, that's supposed to be c to the 6th.
There we go. So my final answer should have been 30, a squared c to the 6th. There we go. And then number 32, Lana.
Positive 6x, positive 6 x to the 4th, y to the 8th, z cubed.
Great job. Positive because there's 2 negatives. That's an even number of them. 6. Then adding the exponents, x to the 4th, y to the 8th, z cubed. Great job there. All right, so there were 8 of them. How did we do on those 8?
About 7.
7 out of 8?
Did pretty good. I think I was just being dumb. I don't know why I put.
If you were being dumb, then you weren't doing good.
No.
How many did you get out of 8, Joshua?
I think like 6 or something.
Okay, so we missed a couple. All right, those ones that you missed, you understand now?
Yeah.
All right, let's go and finish out the exercise, 33 to 41. 33 to 41. I did good. I was just being dumb. Well, then by definition of good. You're fine. We're just making sure our brains are turned back on after spring breaks. 33 to 41 now. Remember, if they write it without a fraction, those division problems probably ought to be turned into fractions. 34, 35, 39, 40. Did we write them as fractions?
Mm-hmm.
Excellent. All right, let's take a look. Number 33. What did you get for your answer? And we'll start with Lana this time.
3p.
3p is correct. Number 34, Joshua.
Negative 1/5.
Excellent. The c to the sixths cancel, but we're left with negative 1/5. Great job. Lana, number 35.
Positive 32 g to the 14th h cubed.
Uh-oh. You treated it like multiplication.
Well,
If you had multiplied, it would have been positive 32 g to the 14th h cubed. And they gave you that division sign. So let's set it up with a fraction real quick, right? We've got the negative 8g to the 6th, I think it was, over a negative 4g to the 8th h cubed. Lana, what should we have gotten for our answer?
32.
I'm sorry?
Wait, 32. Positive 32.
Well, you're right about the positive, because the two negatives are the same, so positive. We're going to divide 8 by 4. 2. All right. And then we're subtracting exponents, remember, here. So,
over g to the g squared.
over the g squared.
H cubed.
And the h cubed is also in that denominator. It never left. All right? So, yeah, watch out for those division signs. They're sneaky. Sneaky. All
I
right?
was gonna do that at first, but I was.
All right, so did you get the correct answer?
Yeah.
All right, so you get to one-up Lana in this one. All right, number 36. Josh, this was already written as a fraction. That helps.
1 over 2a. Is that right?
Let's see here. What's the sign, first of all?
Negative.
Negative. And can you divide 8 by 16? No, right? 8 doesn't divide by 16. So we have to treat it like a fraction. And you're right, we get
to 1 over 2.
1 over 2. Now, when it comes to the letters, let's look at the a's. In the top I have an a squared. In the bottom I've got an a to the first. So when I subtract the exponents, what am I left with?
Oh, just 1, but at the top.
Right, there's an a to the first, but it's left in the top with the 1, which at this point I guess means we didn't have to write the 1, but it doesn't hurt to have it there. What about the m? It's just kind of there in the top. What do I do with it?
You just leave it in the top.
Leave it there in the top. So 1 am, or just am over, well, negative am over 2, or negative 1 am over 2. Does that make sense? Did you get that, Lana?
Yes.
So you get to one-up him, and now you're even. All right, this is quite the competition, back and forth. Number 37, Lana, let's see if you got it.
5w to the 5th X to the 7.
Did you get it?
Mm-hmm.
Okay, so we're even on that one. 5w to the 5th, x to the 7th. All right, Josh, here we go. Number 38.
Negative 3u over 4v to the 6.
Good job. Did you get it?
Yeah.
Still even. All right, negative 3u over 4v to the 6th is correct. Number 39. Hopefully you wrote it as a fraction and divided instead of multiplied, Alana.
1.
It is just 1. Anytime you divide something by itself, did you get 1?
Yeah.
All right. Number 40, Josh.
4 over 3c.
Did you get that? All right, we're still even. 4 over 3c. And number 41, Lana.
7q squared r over 1p squared.
7q squared r over 1p squared, or just over p squared.
Yeah.
Did you get that? All right, so we both end even with each other, so nobody gets to laugh at anybody else, which is slightly disappointing, but you know. Questions on this? Questions on the division?
No.
All right, turn back if you would to page 482 now. Page 482. Let's practice just a little bit more. The division can give us fits every now and then because there's more weirdness that happens with division, right? Multiplication, really straightforward. Division, there's a little bit more weirdness. So on page 482 at the bottom of the page, I want you to do 16 through 24. Page 482 there in the homework section to numbers 16 through 24. Let's get just a little bit more division practice in. Make sure we're good to go on this. All right, let's see how we did on these. Number 16 was pretty straightforward, Lana.
3g squared.
3g squared. Number 17, a little bit of weirdness there. Joshua?
2z cubed over 7.
Good, 2z cubed over 7. Number 18, pretty straightforward, class. 1. Number 19, Lana?
Negative 2 over 5x to the 4th.
Good, negative 2 over 5x to the 4th. Number 20, Joshua. Looks like Lana got you there, okay.
Yeah. Negative 20y cubed z squared.
I think you misread it. That's a negative 24y. I think you read it as a negative 2y. To get negative 20. Should have reduced the 24 and the 40 by 8 to get what answer, Lana?
Negative 5y cubed z squared over 3.
Yeah, negative 5y cubed z squared over 3. I think you just misread it, and that caused you to get the wrong answer. Let's come back to you, Joshua, number 21, which hopefully you rewrote in fractional form before you divided.
1c squared over 4d.
Good, 1 is c squared over 4d. Number 22, back to Lana.
Negative 4k to the 4th.
Negative 4k to the 4th. How about number 23, Joshua?
3p over q to the 4th.
Good, 3p over q to the 4th. 3p over q to the 4th. Looks like Joshua got you there. All right, is that
I
one
didn't
and
know
one?
it was supposed to be like.
Yeah, she's still
I was confused over the bottom.
Okay. So the key there then would be start by writing it as the fraction. Put the negative 24p squared q cubed over negative 8p q to the 7th. So write it that way first.
But I put it in the top.
Right. Did you write it this way, or did you try to do it without writing it this
I
way?
tried to do it.
That's what's going to get you, right? Is you really need to write it this way so that you can clearly see the q to the 4th has to be in the bottom, but you don't see that if you don't write it this way. Of course, the p there can be a positive, and then 3 over 1 are just 3. All right, and then number 24, back to Lana.
1s squared t to the 4th over 3r cubed.
Good, s squared t to the 4th over 3r cubed is correct. All right, so Lana, you just missed 1. And Joshua, 1 or 2?
I missed like 3.
Missed 3 of them, okay.
Because the last one, I put t cubed instead of t to the 4th.
Ah, you didn't subtract the exponents, you tried to divide the exponents, so be careful there. All right, questions, comments?
Those are a little tricky.
Right, division just is more tricky. That's why I wanted to spend a little extra time on division and do a second round of these to give you some extra practice. All right, if you would go ahead and look right there at the bottom of the page, 482, and then over to the next page. Got some fraction practice here. Go and finish out those blue problems, 25 through, I think it's 20 through 30, 25 through 30. They're on pages 482 to 483, just for the sake of practicing with fractions. You're going to see quite a bit of fractions in Algebra 1. Want to make sure we're good to go there, so quick refresher, has nothing to do with the other stuff we've been working on.
Which grade is Algebra 1?
What?
Which grade is Algebra 1?
Since they're in 8th grade, and I said next year, that would make it,
Oh, I didn't hear you say that.
okay, yeah, 9th grade. let's go ahead and see how we did on these fraction problems. Go ahead and pause where you're at there. Number 25, remember to add fractions, class. You have to have a common denominator. Hopefully you got 24 as your common denominator. So you got 1 and 1/24. 1 and 1/24. Number 26, again, got to get that common denominator. This time 9 is what you're going for. It works out pretty easily. 1 and 1/9, your answer. Number 27, remember with fractions, multiplication, you want to cancel stuff. So like 56 and 49, you can cancel a 7 out of both of those. 46 and 52, you can cancel a 2 out of both of those. And that's the think about all the canceling you do. End up getting 1 and 1/91. Kind of an awful looking answer there. Number 28, remember we never really divide fractions, class. We multiply by the reciprocal. So we're going to make it 6/11 times 7/6. The 6's cancel to give you just 7/11. 7/11. Number 29, remember that complex fraction is a division problem. So it literally says 7/9 divided by 4. But again, we don't divide, we multiply by the reciprocal. So it's 7/9 times 1/4. Nothing cancels. 7/36 is your answer. And then for number 30, again, multiply by the reciprocal. 6/7 times 9/2. And end up doing just a little bit of canceling there to get 3 and 6/7. Of the ones you did, how many got all the ones you did right? Even if you didn't finish them all, you did all the ones you did correctly. Okay, Lana, good to go. Joshua, which of the ones that you did you get wrong?
Really? All of them, because I didn't do them.
Ah, okay. Do we need a quick refresher on how to do them correctly? Or
Yeah.
was me talking through it sufficient, or you want to see it worked out?
I mean, I guess I could see that.
All right, so for instance, number 25, we've got a 6 plus 7 8s, and we're like, well, those don't have the same denominator. So we're going to rewrite both of these as a certain number of 24ths. Stay with me real quick. This becomes 4 24ths. This becomes 21 24ths, which gives you 25 24ths, or 1 and 1/24. Does that help refresh your memory?
I accidentally messed up. I kept it as 25 over 24.
Oh, okay, so it's not entirely wrong. So
Yeah.
you did this part right, just changing it to the mixed number was all. Okay, all right. Do we need any more of them shown, or do you feel like you've got it now?
I got it.
Okay. All right, homework this evening is to do page 485. Page 485, the homework, 1 through 18. Page 485, the homework section, 1 through 18. Take a look at that in our lesson tomorrow. Have a wonderful rest of your day.